Welcome back to the 6th video in the Getting Started with Swift series. In this video we're going to take a look at functions in Swift. Functions allow us to break our code into self-contained chunks of code that perform a specific task. You give a function a name and you can call it whenever you want to perform that task. Okay, well let's get into it now. Okay, so here we are in the playground again. Let's talk a little bit about functions. So every function has a type. This consists of the function's parameters and the return types. Parameters are values that you wish to pass into the function that can be used within that function, and the return type is a value the function can return when it completes. Because a function is a type, this means you can use this type like any other type in Swift. In fact, you can even pass a function in as a parameter and also return a function. Okay, so let's look at how we create a function. Let's look at a simple example here. Let's get rid of all this stuff we were looking at the other day and start creating a function. Okay, so let's unpack this. Firstly, to create a function, we use the keyword func. We then leave a space, and then we provide the actual name of the function, which in this case is say hello. Function names should be chosen so they describe what the function will actually do, and the name should be created in camel case. Now what camel case is basically the first letter is always lowercase, and then when there's multiple words in the function name, they all start with a capital and the rest of the word is lowercase. Next we open and close the normal brackets. If you want to pass parameters to the function, then they should be contained within the brackets. The parameters should be specific names that you want to have in the function, and we also need the type of the actual parameter. And we use the normal notation here. So in this case, we're passing one parameter through called name, and we're using the colon to specify it is a string parameter that gets passed through. If the function is going to return something, then it needs to be specified as well using the dash and then greater than symbol, which looks like an arrow, sort of indicating that it will return something. And in this case, we're returning a string. Now, we refer to this information as the function definition. The definition basically just describes what the function does, what it receives, and what it's going to return. After we've specified the function definition, then we open the curly braces, and you'll notice down the bottom here we've got the close of the curly braces, and all of this code within the curly braces is the actual function code. We're creating a constant called message, and we're basically just setting that to be a string, which is hello and then the name that is being passed in as a parameter here. And then we just return that actual message, and you'll notice the return type is a string, and this is going to be created as a string as well. Okay, so now that we've got this function, how do we actually call it? Okay, well, let's give that actually a go. So let's go let text equals say hello name Fred, and let's actually print that text out. Okay, now if we run that now, you'll note that it's printed out hello Fred, which is the result of what's returned from that function. So that's one way we can use it, but we could also just go print say hello. Okay, so let's try that now. Okay, so because the function is returning a string, we can actually just treat the function as we would just a normal string. So where here we printed the actual string constant, here we can just print the return value from the function directly. So it's basically just being treated as a string data type. Okay, so functions are very flexible. You can create functions that don't take any parameters at all, and this could be an example of one. So in this function, the important thing to note is even though we're not passing any parameters through, we still need to include the open and close brackets. Now let's try calling that. So let's go print grid world. And if we run that again, you'll notice that we actually get that return value straight out. Okay, now you can also pass multiple parameters in, and these just need to be separated by a comma. I like to include a space as well, just to make it more readable. Let's have a look at an example. So func, say hello for age. We'll go name, string, a comma, and then we'll have a second parameter called age. And we want to return a string. Okay, so let's create something in here. So if age is less than, say, 30, return hello name. You aren't so old. Oops. There we go. Else return hello name. You are a little older. There we go. Okay, so we've got our function here that takes two variables, name and age, and it returns a string type. And then we've got some conditional logic in here that we've looked at just previously. If the age is less than 30, we're going to return hello, and then the name, you aren't so old. Else, hello the name, and you're a little older. So let's try calling that. So print, say hello for age, and the name will make Jill, and the age, let's say 23. Again, if we run that. Okay, and you can see that conditional logic has returned this response with the name filled in. Now, if we change this to be 54 maybe, and run again, you'll see now that we get the different return from that conditional logic. Okay, so functions often don't need to actually return a value as well. They just need to do some processing. So if we don't need to return anything, then we can specify the function, without a return. So if we go func, just hello in this case maybe, name, make it a string data type, and then we simply leave out the return arrow and the type. Okay, so what we might do here is just actually put the print hello name in the actual function itself. And if we then call that, we can just go hello name Mac. And if we run that again, you'll notice that we get hello Mac, and there's no return type. Sometimes you can create a function where it actually has a return type, and sometimes you will want to use a return type, and other times you may not want to use a return type. Now, if I try and call maybe one of these functions up here where we actually have a return type, maybe say greet world, if I execute that now, I don't actually receive an error. However, if I was using this in an app, I'd actually get a warning at this case because there's a return type here that's not actually being used. So to get rid of that warning, you can use the underscore to take the place of the actual return parameter. So if we run that again, you can see that there's no difference, nothing's failing or anything like that. However, in an actual app, that would silence the warning that you would be getting here that's saying there's a unused return type, and often it will just suggest replacing it with an underscore. So it's just a way of silencing the errors using the underscore. Okay, so with return data, it's even possible to return multiple values. We do this using a type that we haven't seen before called tuples. Now, a tuple is a group of different values that get represented as one. So let's have a look at this further. So what we might do is just clear out some of this stuff and get us back to scratch. Okay, so tuples can be declared and created like any other types, including using literals. So I can create a tuple like this. So let's go var coord equals x y 100. And basically what I've done here is I've created a tuple called coord, and it's got two named elements in there, one called x, which I've set to a value of 30, and one called y, which I've set to a value of 100. Now, when I want to use those particular values, I can just refer to them by their name. So if I go coord dot x and then run that, you'll see that it prints out the 30. So you can also create the tuple without names and just pass in the values. Now, obviously, I can't refer to it as an x any longer, and I would just refer to it as the first parameter. So if I execute that again, you'll see that it prints out 30 again. And if I was to change that to 1, then you'll see that it prints out the actual second parameter. So let's look at an example where we could use a tuple for a returned value. So we'll just clear that out. And let's go func get min max values, and we will pass this in as an integer array, and we will pass back min, and we'll make that an integer, and max, and we'll also make that an integer. Okay, so let's build up the body of this function here. Okay, so we'll just create a variable called min value, and for the moment we'll set that to int max, and we'll create a variable called max value, and for the moment we will set that to int min. So next what we'll do is we will use a for in loop to iterate over the values array, and inside of here we will go if the number is less than the min value, we will set the min value equal to the number. We'll also have another if number is greater than max, oops, got a typo here, max value, then we will set the max value to be equal to the number. Okay, so effectively what this should do is go through all the values that are passed in that values array, and if the number is less than what the current minimum value, then it should make the minimum value equal the number, and if the number is greater than the maximum value, then it will make the maximum value equal the number. So it should keep moving one towards the minimum and one towards the maximum. So what we want to do is then return the min value and max value, and that's our function. So let's test that out. Let array equals, and let's just load, I don't know, 3, 6, 9, 100 minus 30. So we've loaded an array with a few values here. Now let's call that function. So we could actually let returned values equals get min max, and we're going to pass through the array, and now we can just print, and let's go min equals, and we go returned values dot min, and max equals, and again we can just returned values dot max. And if we give that a run, you can see that we've actually selected the min and the max value, and that's what's been passed out, and then we can just print them directly. So this can be really useful when you want to return additional information from a function. For instance, maybe if you're accessing a website and you've got a status code and you want to actually pass through some error text as well. So you might specify the return something like this. So I'm going to return the status code as an int, and then I'm going to return the error message as a string. And that way you get the code and the actual error at once and can use them accordingly. Okay, there's actually a shortcut for return values as well. So in a function, if the entire body of the function is a single expression, then you don't actually need to use the return keyword. So for example, we could go func hello, maybe name, string, and that returns a string, and the function could simply be hello and you'll see that the error has gone away, indicating that there's no problem with the return value, because it'll just return whatever that single line statement actually generates. I don't like to do this. I like to put the return keyword in there. I think it just makes it clearer what's going on. Okay, so let's have a look in parameters in more detail now. Normally a function will use the parameter name as the argument label. So just to be clear here, this is a parameter name, and then when we use it, this becomes the argument label. Now generally the argument label just uses the actual parameter name, and 90% of the time that's fine. However, you can provide a different argument label if you want to, and all you do is add it to the function call in front of the parameter name with a space separating them. That's then going to use the label when you call the function. So let's have a bit of a look here. We might just clear this stuff out, and let's create func say hello name. It's going to be a string, and then we'll put the argument label that we want in there, and then the parameter name, and that's also going to be a string, and we'll simply print hello name How is, and then again, today. Okay, so you can see we specify the argument label and then the parameter name. In the actual function, we use the parameter name, but externally, if we call that function, say, let's try that again, say hello, you'll notice that it actually uses the argument label rather than the parameter name. Mac from Newcastle. And if we run that, it actually has used that argument. Now, if we want, sometimes it's quite obvious what the parameter is that you're going to actually pass through, and you can actually omit the actual name. So say hello, if I was just passing say hello, something like this. If we execute that, that should work. Ooh, hello. So it may be fairly obvious you're always going to pass a name in. So if I put the underscore and a space in front of the name, then you'll see I don't need to actually specify the name parameter. I can just literally pass the value straight in like that. So it gets used quite a bit in Apple's APIs for a start. Now we can also specify default values to be used for parameters, and then these parameters can be omitted from the function call altogether, and it will just use that default. Now these parameters should be after any parameters that are required though in the actual function definition. So let's have a look at an example here. Let's go func get vehicles, and let's pass through a parameter called bool, but we will make it be false by default, and we will return an array of strings. Okay, we can go let items equal, and then we'll just create an array using literals. Okay, so we've got an array there, and we can go if sorted, and then we can return items as sorted, else we can just return items. So if we go get vehicles without, and you'll notice that it didn't even actually ask for a parameter. Let's go print. Might be a little bit easier for us to see what's going on. Now if we run that, we get car, truck, bus and bikes. So basically it's defaulted the sorted to false, and when we come in here, if the sorted is not true, it will just return the items. However, if we go print get vehicles and we add the parameter, now if we go false, that's going to do exactly the same thing. However, if we set that to true and run it again, okay, and you can see the function where we actually specified sorted to be true actually returns the array sorted. Okay, so there's one last thing I want to cover off on parameters, and to date we've just looked at parameters as values that are passed into functions where they're used as constants in the function and they don't have any effect on the calling code. You can, however, use the InOut keyword to allow a function to modify the value that's passed to it within the function, and that value in where it was called from is also changed. Now obviously you can only pass variables to the functions, as constants still can't be changed no matter what. And you also need to prefix the variable in the function call with an ampersand to indicate that it can be modified by the function. And also any parameters that are labeled with InOut can't have default values set on them. So let's have a bit of a look at this with an example. So if we go func swap ints, and then we have the first int and the second int, and what we might want to do in here is let temp equal first, then we make first equal the second, and then we make second equal to the temp that was stored previously. As you can see, these errors here, we cannot assign a value first to a let constant because these are treated as lets. However, if we go in out here, so that error will go away, and that's hunky-dory. Now, as far as calling it, let's create a var test1 equals 35. Create a second one, test2 equals 45, and then we can go swap. And you'll notice here that in the definition, it's actually specifying that actual ampersand there. So if we select that, it's already actually put the ampersand in front of it for us. So we can put test1 in here, test2 in here, and we can print test1 equals test1 and test2 equals. Okay, now if we run that, you'll notice that the values have indeed been swapped outside of the actual function as well as inside the function. Okay, well, I think that's enough for this video, so I'm going to end it here. In the next video, we'll look more at function types in more detail, and then we'll actually look at closures, which is essentially passing functions into functions or returning functions. Well, thanks for watching this video. If you like what you've seen, then can I get you to give the video a like? And if you'd like to see more, then hit the subscribe button. And if you hit the chime, you'll get notified of when I put up new videos. Okay, cheers for now.